This is going to be a video on adding and subtracting polynomials. So before we add and subtract, the first thing we should do is make sure we have a definition of what a polynomial is. So we have a polynomial is a finite sum of terms. When we say finite, we just means that, it stops at some point. So a finite sum of terms in which all variables have whole number exponents. So when we say whole number exponents, we mean no negatives, and we also mean no fractions. So all variables have whole number exponents, and no variables appear in the denominator. Now, that doesn't mean that you can't have fractions. What it really just means is that you can't have variables in the denominator for a fraction. So let's just do a quick list of things that are polynomials and then things that are not. So for polynomials, something along the lines of x to the fourth plus 3x squared minus 7x plus 1. That's something that has a form. It's a finite number of terms. It's got all the variables with whole number exponents. And there's no variables in any denominators. Another example could be something like this: 2xy squared plus 7x to the fifth y to the fourth minus 3x. Again, it meets the requirements. All the exponents are whole numbers. There's no variables in the denominator. It's a finite sum of terms. It's important to recognize that you can have more than one variable in a polynomial. And we'll just look at one more. Something like 1/3 y squared plus 8xy minus 7. So another example of a polynomial, all the variables have whole number exponents. There are no variables in the denominator. There's a fraction, right, the 1/3, but that doesn't stop it from being a polynomial. The coefficients can be fractions, in other words, just the variables can't be in the denominators. And then sometimes it's easier to think of, things that are not polynomials, just so you can see the difference. So these ones are not polynomials over here. So something like 3x squared plus 5 over 2x minus 8. And that's not a polynomial because we have a variable in the denominator, right? So recognizing that won't be a polynomial. Another example, if I said 4y to the fifth minus 2x to the negative third power plus 7. Kind of looks like a polynomial, but that exponent being negative, right, is not a whole number. In other words, it's got a negative value. So a negative exponent tells you it's not a polynomial. That's how you're recognizing it. And then lastly, I'll put this one here: 5x squared plus 4x minus 8x to the 1/2 power. Again, this is not a polynomial. The reason being is that the exponent here is not a whole number, right? It's a fraction. for the exponent. So identifying polynomials and things that are not polynomials is important. And then we're going to talk about the terms of a polynomial. So as we talk about this, we're going to talk about the degree. So degree of a term with one variable is equal to the exponent on the variable. So the degree here, at degree of a term with one variable. That's the important thing is we're talking about a term with one variable in it. So an example of something that would look like that would be something like 5x to the fourth. That's one term because there's no addition or subtraction going on here. So you can tell something's a term. It only has one variable in it. And the degree here would be just 4 because that's the exponent. Looking at another one, if I said something like negative 2x to the 7th, the degree here, remember, is the exponent on the variable, which would just be 7. Now something that's similar but a little different, if I talk about the degree of a term with more than one variable, right? It's still a term with more than one variable this time. Is equal to the sum of the exponents on the variables. Remember when I say sum, I'm saying you want to add them together, in other words. So let's just look at a couple examples. If I said I had 4x squared y to the third. So again, this is just one term because there's no addition or subtraction going on. If I wanted to find the degree of this term, now since there's more than one variable in there, I'm going to add the exponents I see. So the degree of this would be the 2 plus the 3, which gives me a degree of 5. I'm going to take a look at one more. If I said something like negative 3x to the 6th, y to the 2nd, z to the 3rd. Again, this is one term because there's no addition or subtraction going on. And we want to add up the exponents, right? The sum of the exponents gives us the degree. So 6 plus 2 gives me 8 plus 3. Looks like the degree here is 11. So the last two definitions here talked about the degree of a term, whether it had one variable or more than one variable. We can also talk about what we call the degree of the polynomial. So that's a little different because we're talking about the entire thing now. So the degree of polynomial is the same as the degree of the highest term. So pretty much if you write a polynomial out, you're looking for the degree of each term, and then whatever the highest one is the one that's the degree of the polynomial. So for the first example, if I said 4x squared plus 7x to the fifth minus 2x to the third plus 9, and I'm trying to find the degree here, I'm looking at each term individually. So the degree of this first term, remember terms are separated by addition or subtraction, the degree of the first term is 2. The degree of the second term would be 5. The degree of the third term is 3, and the degree of the fourth term really is 0 because you don't see a variable there with a power, so the power is 0. But if I wanted the highest degree I see out of all of these, that would be the degree of 5. And that's the degree of the polynomial then. Right? So I'm really just looking at the degree of each of these individually, and I want the highest one I have. Taking a look at another one, if I had 3x y squared minus 2x to the fourth plus 7y to the fifth minus 8x y to the ninth. Again, we're going to try to find the degree of the entire polynomial. So thinking about this for a minute, you really have to think about what's the degree of each term first, and then you want the highest one of those that you see. So for the first term, the 3xy squared, the degree of this term, be very careful. The power on the y is 2. The power on the x, though, is 1. So the degree of this term, remember you add them together, 1 plus 2. The degree here would be 3. For the second term, the negative 2x to the fourth, the degree here is just the power on the x because there's only one variable, so that'd be 4. For the next term, 7y to the fifth, the degree would be 5 because it's the highest power you have. And for 8x y to the ninth, again, remember this x really has a power of 1 on there. When you have more than one variable, you add the powers, so this will be a degree of 10. So the highest value I see on that list is 10, so the degree would be 10 for that polynomial. Alright, now that we've talked about polynomials and their degree, we'll talk about how to add them or subtract them. So, to add, I'll just say slash subtract because it really is the same process. So to add or subtract polynomials, you want to distribute to remove parentheses, then combine like terms. So you've probably done this somewhere before. We'll do a few examples. First one we'll just say to add. So the first polynomial in parentheses, I'll write is 3x squared minus 2x plus 7. Close that parentheses, so that's the first polynomial. And then we're going to add, so plus in parentheses 2x squared plus x minus 3. Now, first off, it's important to recognize the operation because it says add here, but it could say perform the indicated operation. You know it's add because there's a plus sign in between them. If there was no plus sign there, it actually means multiply. So be paying attention to that because people do the wrong thing sometimes. You got to look for that sign. If it's a plus sign, it means add. So to add these, really first you have to distribute to remove the parentheses before you can combine any like terms. So on this first polynomial, there's nothing to distribute through here. It's really like a positive 1 times this. So you can just drop those parentheses. So you're left with 3x squared minus 2x plus 7. And then for the next set of parentheses, this is really like a positive 1 in front. So 1 times anything is just itself. So when you have a plus sign here, it's really like a positive 1 here gets distributed through, but it really just gives you itself back out. So you can just drop the parentheses really and write this as plus 2x squared plus x minus 3. Now, if this had been subtraction, if this was a negative sign, you would multiply the negative through to each piece by distributing, which would change the signs. But because it's addition, we're just going to drop the parentheses because you don't really need it, because 1 times anything is just itself. All right, once we've removed parentheses, now we'll combine like terms. Remember, like terms are terms that have the same variables with the exact same exponents. We did this earlier. So 3x squared plus 2x squared gives us 5x squared. Negative 2x plus x gives me negative x. And a positive 7 minus 3 gives me positive 4. And now keeping in mind from here forward, these aren't like terms at all, so you can't go any further. And that would be your answer, 5x squared minus x plus 4. We say this is written in descending order with the highest powers coming first and the lowest degree terms coming after it in order. Typically you'll see things written in descending order. We'll take a look at another one here. If I said to subtract first polynomial will be x to the third plus 3x plus 9 minus in parentheses negative x squared minus 4x plus 2, so the second polynomial. And again, the first thing we want to do is remove parentheses, either by distributing or just noticing that it's 1 times itself. On this first one, I can drop these parentheses because really there's nothing to multiply into it. So we just have x to the third plus 3x plus 9. For the second one, you cannot just drop the parentheses. You actually have to think about, this is really like a negative 1 in front. When you see a minus sign here, it's really like a negative 1. And it's being multiplied to everything, so you have to distribute it through. When you do that, it's going to change the signs. A negative 1 times a negative x squared makes it a positive x squared. A negative 1 times a negative 4x makes it a positive 4x. And a negative 1 times a positive 2 makes this negative 2. Once you're here, you want to combine like terms. Noticing that, if it doesn't have a like term, you just leave it. So like x to the third, remember, to be a like term would also have to have the same variable with the same exponent. There are no other x to the thirds here, so x to the third would just stay. Because I want to do this in descending order, the next term I would try to find is anything with an x squared. If you have this x squared, there are no other x squared terms, so just plus x squared. Make sure you keep the sign with it. And then the next terms would be x terms, x to the first power. We got positive 3x plus 4x, so that makes us plus 7x. And then we have positive 9 minus 2, which makes this plus 7. At this point, you should check to see if there's any like terms you might have missed, but there are not, because the powers are all different on those variables. So that's it. Let's take a look at a couple more. If I said to subtract negative 2x squared plus 5x minus 13 from the next polynomial will be 3x squared minus 2x plus 9. So the first thing you should notice is how I wrote this. I didn't write it with the operation already in there. It's telling us to subtract, and it's saying to take this first polynomial away from the second one. So whenever you take away from something, when you subtract from something, you have to write that first. So this really means that you want to write 3x squared minus 2x plus 9 first, minus, you're taking away the second one from it, or the first one from it, pardon me, minus 2x squared plus 5x minus 13. So the order that you put these in is important because your signs won't be the same otherwise. So you're taking the first one away from the second one. You always put the second one first. All right, and then you subtract the first one away from it. Once we're here, now we proceed as normal. In this first one, there's no value to multiply through, so we can just drop the parentheses, you get 3x squared minus 2x plus 9. Here, this is a negative. Remember, if you have subtraction of a polynomial, there's going to be really a negative 1 in front. It means you have to multiply the negative through. The negative belongs to all the terms. So multiplying the negative through, a negative 1 times negative 2x squared makes it positive 2x squared. A negative 1 times a positive 5x makes it negative 5x. And a negative 1 times a negative 13 makes this plus 13. Once you're here, your parentheses are gone. You can combine like terms. I would do it in descending order. So I have 3x squared plus 2x squared, which makes this 5x squared. I have negative 2x minus 5x, which makes this negative 7x. And I got plus 9 plus 13, which makes that positive 22. Again, none of these are like terms, so you just leave it as is. Alright, and we'll just take a look at one more here. So, say to add. And the first one we'll look at is 5a squared b plus ab plus 2b. So that's the first polynomial. Plus 7a squared b minus b minus 3ab plus 4. We want to add these together. If it didn't say add and it said perform an indicated operation, you know it's add because there's a plus sign in between them. That's telling you to add these. So the first thing we want to do is remove parentheses. Removing parentheses from the first one, there's no coefficient to multiply through, so we can just drop those parentheses. You have 5a squared b plus ab plus 2b. Plus here, there's really like a positive 1 in front of this. Remember, if there's a positive 1 times anything, it just gives you itself. So you can drop these parentheses and just write what you have. So still need a plus. So plus 7a squared b minus b minus 3ab plus 4. And then lastly, we want to combine like terms. Remember, like terms have the same variables, the same exponents. So I got a 5a squared b here, and I can combine that with anything that also has an a squared b, the same variables, the exact same exponents. So we have a positive 7a squared b, so it's going to give me 12a squared b. And then you might notice that you have an ab term here. Anything else that has an ab would be a like term with it, so ab minus 3ab makes this is really like a 1. Make sure you recognize there's really like a 1ab there, right? So positive 1 minus 3 is just a negative 2ab. So that, sign of being negative becomes your operation. So it's minus 2ab. We've got a plus 2b. And that combines with a negative b. So 2b minus b will be a positive. Remember, there's really a 1 here, so 2 minus 1 is positive 1b, or just positive b. And then lastly, that plus 4 is just a constant on the end. Keeping in mind, none of these combine here because they aren't like terms. Remember, like terms have to have the exact same variables to the exact same powers, and we don't have that with any of these. So you're going to leave that just as is. Alright, so hopefully you found that video helpful on adding and subtracting polynomials.